Okay. Gonna go ahead and get started. Before we hop into the topic for today, just a couple of things logistically. First, as you're probably aware, the extensions are due today. So hopefully you've already gotten some of those turned in or all of them turned in. If you want to use your late coupons on those, then that's totally fine. So if you don't have them all done yet and you want to turn some in at office hours later on this week, or come in and see me in my office later this week and turn some in, that's totally fine. There's extra credit available as well, so be sure to take a look at that opportunity if you're interested in earning some extra credit points. Yeah, those are all due today. The other thing that I wanted to make sure everybody was aware of, I sent out the exam grades before class this morning, so you should have gotten a couple of emails from me about that. There's information about that on Piazza, so if you, I'm certainly happy to discuss the exam with anybody. So if you're interested in talking about the exam problems, you want to know, why you missed some points, or you want to go over the answers, go over some things that you missed, be happy to talk to you about those kinds of things in class, in office hours, wherever you'd like. If you think that something's been done incorrectly, then please be sure to submit a regrade request through GradeScope. The TAs can't help you with that kind of stuff. Those all go directly to me. I think that's all. Did any of you have any questions about extensions or exam stuff before we hop into today's topic? All right, fantastic. Oh yeah, question. Exclamation point, yeah.
What should be the answers for that question?
I believe the answer to that question would be true with an exclamation point on the end.
But when I run that in the Eclipse, it gives an error message saying we cannot compare int and string. Because it will perform the plus sign first, and then it will perform the greater than.
Well, if you think there's been a grading issue, be sure to submit that through GradeScope, and I can take a look at it. I mean, the way I explained it is definitely how it was graded. So if you are concerned about that, submit a regrade request, and I'll take a look at it. I'm not going to take a look at it right now, though, just because I want to make sure that we have time to get through the material today.
Submit through the GradeScope.
Yep.
Thank you.
Okay. Yeah, so this topic, the topic that we're looking at today, has to do with something called, so you can see that the name of the module is input and output, but actually I think the more important topic that I hope you kind of take away from this is something called an application programming interface. So, or API for short. You'll hear me refer to it as an API. So the reason why it's so important to talk about APIs, the reason why I want you to think about these things and learn about them and learn how to use them, consider that there are lots of things that our programs are expected to have in common. So one thing that I expect, lots of computer programs to want to do, for example, is read input from the keyboard. So if somebody types something in, I want to be able to see what that is and get that into my program so that I can then do something with that. That's pretty standard. We know how to do that. We've seen how to use Scanner to do stuff like that since the first day of class, but I haven't really explained to you what Scanner actually is, or why it exists, or where it came from, right? We just kind of said, here's this thing, use it. Well, Scanner is an example of an API that is used for processing text, processing things coming in to your program. The reason why it exists, where did it come from? It's part of what we'd call the Java standard library. It's just a set of things that you get for free just by writing code in Java. And the idea behind it is that instead of making all of the programmers have to redo this stuff every time they want to get input from a user, there's actually a lot involved, right? I have to check which key is pressed. I have to wait for them to press the enter key. I have to send all that information from the keyboard into the code. That's all work that Scanner is doing for us, right? If Scanner didn't exist, we would have to do those things ourselves every single time that we wanted to get some input from the user. It's a very complicated process, and it's not necessary. You may have heard this term, reinventing the wheel, right? This idea that instead of, coming up with this idea over and over and over again, I'm just going to use the one that already exists, right? Like, I don't need to make my own version of the wheel. I know what the wheel is. I can just use it. You don't even necessarily have to understand how it works. How does Scanner tell which keys are pressed? How does Scanner know that the enter key has been pressed? I don't know. I've been using it for a long time, and it's not really relevant to me, right? I know that it does what it does, and so as a programmer, I know that anytime I need to get input from my users, I can use Scanner to help me do that. So the actual API itself really, I opened it in another tab already, is this. So, I've linked to this directly from the prep work, or if you Googled Scanner in Java, this is a page that I would expect you to stumble across, or one that looks very similar to it. May not be this exact one. This is a pretty standard API page for Java, for Java programs. And so you see that right up at the top, it gives us some information about the scanner. I see some very simple instructions about how to set it up and use it. Right? So this is something like you saw on the first day of class. But if you weren't taking a class and you wanted to know how to do this, well, here it is, right here, right here in this nice reference material. Okay, and further on down it shows you, okay, here's something new that we haven't seen before, but we're going to see it soon. We can use Scanner with files. So instead of actually reading information from what the person typed in on the keyboard, I can actually have it read information in from a file if I want to as well. That's useful. Here's some instructions on how you can do that. And if you scroll down, you'll see instructions on how to do stuff that maybe isn't relevant to what we're doing. So there's a section here on localized numbers. I've been programming for 15 years, and I can tell you I've never used localized numbers in my life. I don't even really know what they're used for. It's never been relevant to me. So as programmers, it is now sort of becoming our responsibility to figure out, okay, what tools are available to me, right? These ones don't make sense. These ones aren't relevant, right? But these ones are. So I'm going to take these tools and apply them to whatever problem it is that I'm trying to solve, that I'm trying to make happen. So if we scroll down, the most interesting part of the API, I think, comes down here, where you'll see there's this box called the Constructor Summary. We'll come back and talk about that a little bit later on this semester. I'm going to scroll down to this one, Method Summary. You may have heard that word method tossed around a few times before now. But we haven't actually told you what it means yet, although if you look at the topic for next week, it's methods. So we're going to tell you exactly what a method is next week. For now, you can treat it as an action, a behavior, a function, right? All very similar ways to think of a method. These are things that Scanner can do. These are the operations that the Scanner can perform for us. So again, it's my job as the programmer to go through this list of operations and recognize, all right, I am trying to do this. Which of these operations on this list do I need in order to accomplish that, right? Some of these things are going to be relevant, some of them are not. And so if you scroll through this list, you'll see things that you recognize. For example, next int right here. That's an action that we've seen before. We've used that plenty of times. Here's next line. Right? We've used that plenty of times. There's also stuff on here that you have not seen before, probably, or thought about or used before. There's stuff on here that I have not used before. And again, I've been programming for a long time, right? So I just have not had the need to use all of this stuff. Maybe someday I will, but up until this point I have not. But the idea is, okay, I have a program. I know I need to get some information from a user. I know I want them to type in integer values, so I've located this method called nextInt that seems like it might be relevant to me. You can actually click on this and it'll take you to a much more detailed description of what this can do for us. So it tells us, the basic description. This all looks like a bunch of, I understand some of these words. That's the other kind of thing that's a little bit scary for folks, is that, especially when you're new, reading these may not make a lot of sense. You're going to have to, at some point in time, I think, put some trust into this code that it's going to do what it says it's going to do. Or maybe even just experiment with it a little bit, play around with it in your own code a little bit, try it a few different times, and get a feel for how it works. But this is telling you what this is trying to do. Even if you only understand this part, scans the next token of the input as an int, right? That's pretty straightforward enough. Gives me the next thing that was typed in as an integer value, basically, right? There's some stuff down here. What happens if there's problems? So if they type in a string instead, I might see something that looks like this. That's what these are trying to tell me. Right? So lots of information here about what this action can do and what it can be used for. Okay, so with that in mind, I do want to show you a new use of Scanner using files. We're going to start using files a lot in this class, starting with this week's homework assignment, actually, as a matter of fact. So let's take a peek at this stats program real quick. Up here at the top, these 4 lines of code, you can see it says, code for setting up Scanner with a file, not your responsibility to understand this part. So this, you can kind of treat as just magic words to get stuff done that needs to happen. But I want to be clear that it's not actually that complicated. These 2 lines pop up a little box on the screen that allow me to pick a file. And I'm sure you've seen windows that look very similar to this on the computer before. Then these 2 lines retrieve whatever file I've selected and feed it into the scanner. That's how this code works. There's a little bit more to it than that. If you want to go more into the details, I'd be happy to talk to you about it sometime. But you're really not responsible for understanding about how all this stuff works. That's also a very common thing as a programmer, to use code and maybe not necessarily understand every single last detail of how it works. Now, certainly I don't like that situation. I would much prefer to understand my code, right? But part of being a programmer is willing to take that leap on a piece of code that you're not entirely sure about and play around with it and experiment and see if you can figure it out, right? Computers are very open to guess and check, testing and checking, right? Trying stuff out, experimenting. Okay, so this is going to pop open the box and read in whatever file. So here's the box that pops up, and you can see there's a couple files here, and it's just gonna, whatever file I select gets fed into the scanner. Down here is the part that I actually want to focus on. So this is sort of the new stuff. In particular, this has next double method from the scanner. We haven't seen that before. That's new. So if you take a look at the API, we can actually go find it and read about it if we want to. Let me just search for it. Has next double. There it is. All right. Returns true if the next thing can be interpreted as a double value. Returns true if the next thing can be interpreted as a double value. So basically, here's what that means, right? I'm looking at the file or whatever the user typed in or whatever the case may be. If I can look at it and it's a decimal value, it's a number, then this is going to say true. If I look at that thing and it's a string or something that's not a decimal number, then this is going to say false. So think about what that means in the context of this code. This says, while there are more decimal values to be read into my program. That's the way I interpret this while loop. While there are more numbers for me to read. This line of code here is going to then read in, perform the actual act of reading in that value. We've seen this before, right? We've seen this. The difference now is that I'm performing it on the file that was selected as opposed to the keyboard, the information that's being typed on the keyboard. So if I run this one more time for you and select, this file here, we can see that, okay, there are the contents of the file just dumped into so it just printed out, right? Printed out onto the console. Does that make sense so far? There's an exercise that I kind of want to work on you, but does everybody understand where we're at so far? So one of the exercises for this problem, I'm not going to do the whole exercise, but I'll do at least part of it, wants you to compute like the maximum and the minimum and the average and stuff like that of all of these values. And so let's start with the count, the number. I'm going to make a counter variable, and then inside of this loop, what I should do is just increment that by 1, right? And then once this loop is over, I can just print out how many values I've counted and see the total quantity. So let's do that. The name of the file is called 1K doubles, and there are in fact 1,000 numbers in that file. Go figure. Just as we expected. Okay, great. Now let's try and do something maybe a little bit more complicated. Let's try and do the average. So I have the count, that's part of the average. I need to get the sum. That's the other part. So let's make another variable for the sum. And I'm going to try to do something like this, where I say sum plus equals in dot next double. Okay, so this should, grab the next value and add it into my sum. But I made a mistake here. There's actually a problem here. Ah, you already know what the problem is going to be. Good. The count has dropped. There's no longer it's now telling me there's only 500 numbers instead of 1,000. That's concerning, right? It's the exact same file. I didn't change the file at all. The only thing I changed was the code. This is a common mistake. I made this on purpose to show you a very, very, very common thing that people run into, which is that anytime I use, in dot next double, it actually consumes that value. I quite literally have an image of Pac-Man just going, right? Munching that value up. I've used it, it's gone. When I call in dot next double the next time, here I was intending for this to refer to the same value that was here, but that's not what's happening. It's going to take the next one, right? So every time through this loop, the way that this code is written, I am consuming 2 values, which is why the count drops in half, right? I read 2 values per trip through the loop instead of just 1. What I meant to do, or what I was, trying to do, is probably something a little bit more like this. Take a variable for this value, right? And now I can reference that variable. I can use that variable in my code whenever I want to. I'm now down to just seeing, this happened 1 time, right? I'm only going to consume 1 value per loop, and I can just use this variable whenever I need to inside of the loop. I'm not going to compute the actual average because I don't care what the actual average is, right? But can show you that after I fix this mistake, the count returns to 1,000 as I would expect it to be. So that's one common thing that people can run into. And you're going to be doing something very similar to this on the very next homework assignment. So keep this in mind when you start working on homework assignment 4. Any questions about this part before I move on to the next? All right. I'm going to take a look at another API now, sort of the main one for this week. So Scanner is an API that we've already used, and we're going to keep using it. It's very useful. So we're not going to stop using the Scanner one. We'll show you more and more things you can do with it as time goes on. But the one I want to show you today is called Standard Draw. And so what its name sort of implies for us is that it can draw things on the screen. And that's a lot of what we're going to be using it for. So we're going to be doing some geometry today. Not a lot of complicated geometry. We're going to keep it very simple, right? But definitely doing a little bit of geometry today. Standard Draw, though, can do more than just draw things on the screen. It can also interact with the keyboard and the mouse. It can also interact with files. It can also do audio, so sound, music, things like that. All possible through Standard Draw. And we'll show you a lot of those things, but we're not going to show you everything that it can do. If you want to see everything that it can do, though, there's a link to the Standard Draw API, or here it is right here. And you'll notice that just like we saw before up at the top, there's some explanation about all the different stuff that Standard Draw can do for us. And then if I scroll down here, eventually we'll see here's a list of, here's the method summary, here's a list of all of the things that Standard Draw can do for us, right? And I'm going to show you some of these things as we go through the exercises and examples today, give you a feel for it. But what I'm hoping to get you to as programmers is the idea that eventually you'll be at a place where instead of me having to show you how something works, I can say, you know, here is an API that is used to draw stuff on the screen. Go look at it and then use it to do this. That's programming, right? I shouldn't have to show you how to use the API. As programmers, we learn how to use APIs and apply them towards our problems. That's our job. But let's take a look at some examples of how this API works. We're going to start with just a simple demo of how we can draw stuff on the screen. So this graphics demo is our first stop here. You can see that we can use built-in colors for the things that get drawn on the screen by typing the name of the color that we want. Or if we want to, we can create our own custom colors. Some of you may be familiar with how this works already if you've done any kind of graphics work before. But the way to interpret these customized colors is 3 color components. There's a red component, a green component, and a blue component, where each of those are going to be values between 0 and 255, where 0 is, you know, none of it, and 255 is a lot. So the way to interpret this would be 255. That's a lot of red, as much red as I possibly can, right? No green, so green is at 0, and the blue is somewhere in the middle, right? Somewhere in the middle. So it should be, give me a color that's kind of pink purple looking, is the idea. But you can, of course, tweak these values and combine those colors to get any color that you want. And so if I run this program, we'll see, okay, I do in fact get some shapes on the screen. There's my green square. There's my pinkish purple circle, right? But if I take a look at this, for example, so this is the line of code that I think quite obviously is used to draw the square on the screen, and then I see these numbers. But what the heck? Like, I have no idea just from looking at them what these numbers represent, right? You might be able to take a guess, but it's not immediately obvious to me what these numbers represent or what these numbers represent. But that's what the API is for. That's what the API can tell us. So let's go back here. I know that it's called filled square or square, either one. All right, there's filled square. If I want to, I can just click and go directly to, it says, all right, here we go, x, the x coordinate of the center of the square. Okay, y, the y coordinate of the center of the square, and then half length, 1/2 the length of any side of the square, or the radius, right? I know that's usually used for circles, but same idea. So here we see a description of what those numbers actually represent. So if I want to draw a different square, right, I can tweak these values. It told me this is the x value, so maybe I want to move my square a little bit to the left. That means I'm going to make this x value a little bit smaller, right? Maybe I think my square is too big. It told me that this represents the radius of the square, so I'm going to make it a little bit smaller. And now I would expect to see that same picture, just with the square moved to the left and a little bit smaller, right? And now we can, you know, use these in whatever way we need to make whatever it is that we're trying to make on the computer, on our canvas. So that's one way to use an API where we've got some code, we're trying to understand it, right? I'm looking at a piece of code, I kind of get a feel for how it works, but I don't know exactly how it works. I think the more common way to use an API is I want to do something. And I have a feeling that, I might be able to use this API to do it, but how? How do I actually do that, right? So one of the exercises down here, I'm not going to do all of them, but I actually want to do this one. Draw an unfilled red triangle somewhere. Okay. I wish to draw a triangle. I'm drawing lots of other shapes. Why not triangles? So I really hope your first inclination would be to do something like this, to go to the Standard Draw API and maybe do a search for triangle, right? Whoops. The word triangle does not appear anywhere in this document. Square does. We saw square. We saw squares. We saw here it says right in the overview, points, lines, squares, circles, and other geometric shapes. Well, but how? Squares, circles, rectangles, ellipses, circular arcs. Ah, polygons. Triangles are polygons. That counts, right? Okay. And for polygon, it's telling me that I get two arrays of doubles, one for the x coordinates and one for the y coordinates. In fact, we've seen arrays used similarly to this before. This is very much an example of parallel arrays, two arrays being used together. The idea here being that if I want to draw a triangle, these arrays are going to have three values in them, right? One for each corner of the polygon that I'm drawing. Make sense? So, okay, let's think about this from a programming perspective. And in order to use this polygon method, I need to have arrays. One array for the x values and one array for the y values. Well, I know how to make arrays, so let's do that. Double array x equals, and it didn't tell you what kind of triangle it had to be, right? So it doesn't really matter what these points are, what these values are. As long as there's three of them, it should be a triangle, right? Okay. It does say that it wants it to be red. So that's the pen color. So we've seen how to change the pen color already. And here's another neat little tip too, right? You'll notice that as I type standard draw and then I hit the dot, that Eclipse pops up this window that shows me the list of methods. This is quite literally the API. This is the same exact thing. Look, if I find the Eclipse entry for set pen color, you can see in this little yellow box out here, sets the pen color, the specified color, the predefined pen colors, blah, 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 blah. If I come back over here to the web page, right, set pen color. Let's go find the entry for setting the pen color. Set the pen color to the specified color. The predefined pen colors are blah, 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 blah. It's the exact same thing. It is quite literally the exact same information. So I honestly don't really care where you ultimately get it from, whether you get it from the website, whether you get it from this fancy little box in Eclipse that pops up, right? The important thing is that you understand how to interpret that information that's available to you. All right, so I've got my two arrays. I've changed my pen color to be red. The final step then would be to draw the polygon, which we're going to do by just saying polygon. And then Eclipse is smart. It's already detected that I've got two double arrays and plugged them right in for me. That's convenient, right? Let's try it out, see if we get that red triangle showing up. Okay, it looks more like a line. I think that's probably just because of the points that I chose. Let me try a different point here. Fiddle with the numbers a little bit until I get a proper triangle. Okay, there we go, yeah. Just had bad numbers. That's better. So I hope I actually think that, and I did this on purpose, I actually think that of the ones listed here, this one's probably the hardest. I wanted to do one of the trickier ones. I think some of these other ones should be a bit more straightforward, but I do hope that you try them and make sure you understand how you would do some stuff like this. Any questions before we move on to the next one? All right, we're going to come back to graphics and drawing and shapes and colors and stuff a little bit later. We're actually going to take, I think, a quick detour first and look at the mouse and keyboard. Okay, so we've already used Scanner to read text in, and the way that Standard Draw uses the keyboard is actually pretty different than how a scanner uses the keyboard from how we've used the keyboard with Scanner. And that's not necessarily a bad thing. Scanner is very good at what it does. Standard Draw's use of the keyboard is more like what you would expect to see if you were playing a video game, for example. It's more like that usage of the keyboard, whereas the Scanner is a bit more, well, you've seen it, right? How Scanner works, prompting people for values and then taking them in. But we haven't seen how the mouse works at all. So I want to kind of show you some examples about how to do this stuff. And one thing to keep in mind when working with the keyboard and the mouse, and anything actually, drawing as well, is that the computers are very fast. Very, very, very fast. Very fast. So the idea behind, checking to see if a key has been typed or checking to see if the mouse has been pressed, we actually require the computer to sort of slow down a little bit. The idea here is that the person sitting at the computer is the one who ultimately decides when to press the key or press the mouse. And we don't know when that's going to happen. They may never choose to press a key, right? Or they may press a whole bunch of keys. And our program needs to be able to accommodate both of those situations. So the way that this code is written is that it's going to wait however long it needs to until a key has been pressed. And the way that it does that is by using this has next key typed method. So here's how to think about the way that Standard Draw views keyboard input. Unlike Scanner, so with Scanner I type in something and I hit enter and then it gets sent to my program, right? That's how Scanner works. Standard Draw works a little bit differently. When I push a key, Standard Draw is just going to write that down. Oh, you push the H key, right? Oh, you push the L key. Oh, you push the P key. So it's just going to write down all of the keys that I pushed in the order that I pushed them in. This is what we call a buffer or a queue of keys. And then anytime that I'm checking to see if a key has been pressed, I'm going to say, give me the next key that's been pressed. And it's just going to look at the very front of that line and just give you that letter. So if I pushed, if I type the word hello, H-E-L-L-O, right? Those are all just going to be sitting there and waiting until I say, give me the next key that was typed. And then I'll get the H first. And then I'll say, give me the next key that was typed after that. And then it'll give me the E. And I'll say, give me the next one that was typed after that. And it'll give me the L, right? So that's how the code works. So this method here is not telling me which key has been pressed. It is more like asking the question, have any keys been pressed yet? If a key has been pressed, if there are any keys waiting, then this will be true. Because this is out in front, right? That then becomes false. So the way to interpret this is, while there has not been a key pressed, I'm going to sit here and I'm going to wait. The way that the code is written, you actually don't see this. So if I run this program, it's a little annoying because I can't see the waiting. There's nothing that I can actually see, but the program is running and it's waiting for me to type something. So let me insert something so we can actually see that. Waiting. All right, I'm just going to have a message print out that tells us, yes, we are in fact waiting. All right, there we go. Waiting, 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 waiting. so the way to interpret this number, this 100, that's in milliseconds, right? So this is pausing for 1/10 of a second. So every 10th of a second, it's checking to see if I've pressed a key yet. And it's just waiting. And it will wait here forever. If I walk away from my keyboard, then it'll sit here for eternity. And wait for me to press this key. As soon as I do press a key, let's think about what would happen. As soon as I press a key, this becomes true. There is a key that has been typed. This flips it to be false. So the while loop will then exit. It's over now, right? And then I'm going to come down here, and this is the second part of the demo, where I'm actually checking to see what key was pressed. So this is our API call. This is our action from standard draw that says, tell me what key it was that was pushed. Tell me what that key was. And then we use an if statement here to check. If it was a Y, then I'll say yes. If it was an N, then I'll say no. If I pushed any other key that wasn't a Y or an N, then I'm going to say, huh? I don't know. If you want to try this yourself, here's something to keep in mind, right? When you push the key, in order for it to register, you have to have this window active. Even though I'm not drawing any shapes or doing anything, this is the window that's waiting for me to push the key, not Eclipse. So if you're pushing keys on Eclipse, like, why isn't it working? It's because it has to be here. So if I push a key, I'm about to do it. If I push any old key, I'm going to push L, right? It says, what? Didn't recognize that. But if I push one of the ones that it does recognize, so now it's waiting. I'll push Y. Yes. Cool. Got it. Right? This is going to wait for the very first key that's typed and then stop. But if you wanted it to wait for more than one key, you could introduce another loop and just keep doing this over and over again if you wanted to, right? Yeah? That would be a cool little way to extend this out. The mouse actually works pretty similarly to this, but before I switch over and show you how the mouse works, does anybody have any questions about this little keyboard demonstration? Okay, so let's take a look at the mouse next. Right up at the top, I see that we have a loop that says while true. It's going to loop forever. That might seem a little bit odd, but I think it'll actually make sense once I show you how this program works and what it does. And then here is the interesting bit for this program. I'm grabbing the X and Y position of the mouse. So standard draw at any point in time can tell me where the mouse is, the position of the mouse, the X, Y coordinates. I'm also interested in whether or not they push the mouse button. So here I'm using a method called mouse press, and actually you see it's crossed out, and if I hover over this, Eclipse is telling me that it's deprecated. So what this means is that the people who update and maintain this standard draw library, this API, have said that they don't want people to use this anymore. It's old. In fact, what actually happened is that they changed the name. It's now called isMousePressed. So if I switch it to the proper name, Eclipse now becomes happy with me. It would have worked the way that you had it before, but you know, just wanted to update it so that it's a bit more correct now. And then down here I see standard draw, pause, so once per second. So let's think about this. Once per second, it's going to grab the position of the mouse and tell me whether the button's been clicked and print that out. Let's try it. Now again, it's all dependent on the mouse being inside of the window, the standard draw window. So you'll notice that while my mouse is outside of that window, the coordinates are not accurate. Right? It says 0, 0. That's not correct, but it's because I'm out of bounds. I'm not inside the window. As soon as I move inside the window, the coordinates start to reflect the coordinates of the canvas. So just like just like you're familiar with in math class, if I move the mouse down here towards the lower left corner, the values go towards 0, 0. If I move the mouse up here towards the upper right corner, the values go up towards 1, 1. So you can kind of see the bounds of our canvas, right? Just by moving the mouse around and looking at the position. As far as whether the mouse has been pressed or not, so is mouse pressed? Is literally, so I think it's worthy of some clarification. We usually don't talk about mouse presses. We usually talk about mouse clicks. So a click is a press and a release. So when I say is mouse pressed, I'm asking, is the mouse button currently pushed down? Like, is my finger currently on it, pushing the button down? And so you'll see that it's been false the entire time, but as soon as I put my finger on the mouse and hold it, right? I can keep moving the mouse around if I want to, but as long as my finger stays on the button, it'll tell me that the mouse button is pressed, and as soon as I let it go, it'll switch it back and tell me that it's not. Yeah? Does that make sense? Any questions? We're going to do an exercise next, but before we do that, any questions about what's going on here? There's a lot of cool stuff you can do with this, a lot of fun stuff you can do with this. I want to take a look at, I think, the weight point exercise. So here's what the exercise wants us to do. They want us to wait for the user to click the mouse, right? I just explained the difference between a press and a click. A click is a press and a release. So if I click the mouse button, if I push the mouse button and I let it go, I then want to draw something, right? Some shape at whatever position the mouse happens to be at that time. It seems pretty straightforward, right? I mean, you've probably used plenty of applications that have allowed you to do something similar to this. It's not a particularly complicated thing to do, but code-wise, I think you might be a little bit surprised at how much effort is involved. We have to wait for the press, and we have to wait for the release, right? I need to make sure both of those things happen in order to register a click. The good news is it's going to look very similar to what we saw with the keyboard demo, just using the mouse methods instead. So I'm actually going to go back here and grab this while loop. Here I was waiting until the user pressed a key. Now I'm just waiting until they push the mouse. Very similar idea. So I'm going to grab this code and copy it, go back over to the exercise, and instead of has next key typed, I'm going to say is mouse pressed. And I'll update this, waiting for press, right? So I'm not done yet. I just put in one loop, but let's see what happens. I run the code. All right, it's waiting for the press, waiting for me to press the mouse, waiting for me to press the mouse. As soon as I press it, it's done. Loop exited, I'm out. Okay, now I have to do the other half when the mouse has been released. So here I'm saying I'm waiting for the mouse to be pressed, but there's nothing, I can hold that down for as long as I want to, right? The click isn't over until I let it go. So I'm going to have another loop, actually. Switch this to is mouse pressed. And this time, I'm just going to take the exclamation point off. Waiting for release. All right, I'm going to run this now. It's waiting for me to press the mouse. I am going to click and hold the button. It is now waiting for me to let go of the mouse button. As soon as I do that, that second loop exits, right? And the program is over. So we're almost there. The last thing that I need to do is get the position of the mouse and draw something at that spot. I mean, that's probably the easiest part of this exercise. We've seen how to do that. So once I've made it past this loop, I'm going to draw something at the location of the mouse. So get the X and Y position, just like we saw from the prior examples. and then it says to draw a point. I don't care what you draw, right? I'm gonna draw a circle. All right, let's see if it's gonna work. So it's waiting for me to press, waiting for me to release, right? So I'm holding the button down, and then as soon as I release, draws the circle. Okay. I told you it would work for a click though. I mean, if I don't hold the button down, right, I just click the mouse, very similar, right? There's my circle. Cool, right? There's more to this exercise. Asks you checking for the keyboard as well, but I'm going to leave that for you to take a stab at. Any questions about what we've done here before I switch back over to graphics again? Question? I'm sorry, I can't quite hear you. So the first one was the units of position box. Second question was what? Time. Well, so we haven't gotten the so the time. This value here is in milliseconds. Yeah. The position is not a unit of measure necessarily. So because screens are different sizes, right? So your screen is different from my screen, which is different. So that's actually a very complicated topic, an interesting one, way outside the scope of this class. For this class, it's really about the canvas itself. If I think about this window, the bottom left corner is always 0, 0. The top right corner is always 1, 1. It doesn't matter how big this window is, how small this window is. Those are the coordinates. Mm-hmm. Alrighty. So the last topic for today goes back to drawing and things like that, except we're going to add motion into things. Animation. So anytime you want to do animation on the computer, there are 3 parts. The first part is to clear the canvas. Literally just erase everything. And the reason for that is because of how animation works. If you're familiar at all with movies or video games or things like that, the way that we get them to work is by showing you a series of pictures, one after the other, very quickly, right? Where these pictures are called frames. So the idea here is that I'm going to clear the canvas and get ready to draw a new frame. Because there's motion involved, we have to update the positions of anything that has to move. So if you imagine the scene that's being drawn, right, some of the shapes may be stationary, they're not going to move at all. So I can just redraw those in the same position every time. But some things might need to move. So every time I'm getting ready to draw a new frame, I need to figure out what the next position of that thing is going to be. So that when I draw it, it's in a different spot than where it was in the previous frame. That's what makes it look like it's moving. So that's step 2. And then step 3 is to pause briefly. Computers are fast. If we tell the computer to draw frames as fast as it can, it's too fast for our slow human brains to comprehend. We have to tell the computer to give a little bit of time for each frame so that our eyeballs can see it and then those signals can travel up into our brain and be processed, right? That's for us. The good news is that step 1 and step 3 are usually pretty easy, pretty simple. Step 2, however, is almost always going to be the most complicated one to have to deal with. So let's take a look at an example of animation. I want to show you where all these three parts are and explain how it all works. Yeah, question. Pause. Both. Yeah, show. So actually the show command does both. It draws and pauses all in one go. If you want to do them separately, you can. Standard Draw actually provides a way to pause and show separately if you want to. It's the details aren't super relevant for what we are doing, but the flexibility is there. You know, so we're not going to be developing like Pixar movies in this class, right? Like the animation that we're going for is going to be a little crude. It's not going to be the smoothest animation in the world, but that's okay. Those tools are available to you if you want them. I hope that answers your question. But let's take a look at how this actually works with this moving ball demo. So I'm interested in the three pieces of the animation loop. Here's the first step, clearing the canvas. Here's the second step, which I'm going to come back to in just a second. And then here's the third step, drawing the thing on the canvas and then waiting for a little bit. So this value here is how long we're waiting. Again, it's in milliseconds, or another way to think about this, it determines the frame rate. So the frame rate, again, if you are familiar at all with film or video games, you've probably heard of something like 30 frames per second or 60 frames per second. Those are common frame rates. So how long would that be? Well, do the math. Figure out how many milliseconds that would be, and you can adjust the frame rate of your code accordingly by changing how long each frame is displayed. We'll play around with that a little bit later on. First, I actually want to come back to this part right here. So we have a ball in this little demonstration that's going to be moving across the screen. And so I have this variable called ball x that represents the x position of the ball. And you can see that every time I move through this loop, I'm just adding a little bit more to it, a little bit more to it, a little bit more to it, a little bit more to it. So every time I draw that ball, it's just going to be a little bit more to the right, a little bit more to the right, a little bit more to the right. Until eventually, I would expect that that ball is going to go off the edge of the screen, right? The x value becomes greater than 1, it's gone off the edge of the canvas. Well, okay. In that particular situation, I've said just set the x value to be back to 0, which should reset it back at the left side of the screen. Let's run the program and see. Let's make sure that we understand. There's my ball. And there we saw what happens when it gets to the right-hand side of the screen, right? If the x position is greater than 1, it sets it back to 0. Poof, the ball goes back to the next one. So just by changing some of the numbers that we see in here, we can now control this animation. So if I want to make the ball move faster, right, then I can change this to be bigger. That's going to move the ball more, right? It's going to move the ball faster. So if I run the program again here, right, the ball's now moving faster. Yeah? That's cool. Okay. Here's where I'm drawing the ball. So you can see it's using the x variable for the x position, and then it's just hard coding this y position at 0.5. But, you know, I can move the ball up or down if I wanted to, right? And now the ball's a little bit lower on the screen than it was before. That's cool. So I can now tweak these parameters to make the animation work the way that I want it to. Well, let's actually move back to velocity. We call this the velocity, right? So this is not a physics class, but I'm going to do just a very, very basic physics, right? The position where I'm going to be is where I am now, plus how fast I'm moving. It's about as basic as physics gets, right? So that's what this is doing. What if instead of having this be a number, what if, you know, maybe I wanted to make this into a variable? That would then allow me to manipulate the velocity as well, which could be useful to me. If I want, the ball to move in the opposite direction, then I need a negative velocity, right? Or let me show you what I mean by that. I'm going to come up here and double ball velocity equals, whoops, forgot how to type all of a sudden. I'm going to set it back to its original value. Down here, I'm going to use the variable, and now we can actually take this simulation a little bit farther. The motion was a little unnatural, right? When it got to the end of the, edge of the screen, it just went whoop and teleported back. That's not how things really work. Normally, I would expect it to like bounce, right? Okay, what's bouncing? If I was going to the right and I've detected that I've hit the wall, I now need to go to the left. Okay, well, instead of changing my X position, what I actually need to do is change my velocity. And actually, I can just flip the sign. So if it was positive, moving to the right, negative should be moving it to the left. Let's try it. Let's see what happens. There goes my ball. Bounce. That's good. Oh, but it got back to the left hand. So what happened there? It got back to the left-hand side of the screen. There was nothing checking for that, so it just kept on going. It's still going. The position of that, the X position of that ball is very negative and continuing to get more negative. Well, okay, hang on. We can fix that too, right? In fact, it's not that bad. I'm saying flip the velocity if I've gone too far to the right, but I also need to flip the velocity if I've gone too far to the left as well, correct? And I know I've gone too far to the left if the X position is less than 0. So I'm flipping the velocity if the ball X position is greater than 1, or if the ball X position is less than 0. And with that slight modification, I believe that we now have a ball that's going to stay inside the bounds of the screen, right? Now you'll notice that everything that I've been manipulating in this example deals with the X coordinate. I hope that you can see that I could also do similar things in the Y direction, check for bounds in the Y direction. In fact, each ball has 2 values for the position, X and Y. Also has 2 different velocities, X velocity and Y velocity. How fast am I moving in the X direction? How fast am I moving in the Y direction? So one exercise that I would encourage you to do is to take this program and modify it to send that ball flying around and bouncing off all 4 of the walls, not just the left and the right. You should be able to do that. You know enough now to where you should be able to make that ball bounce off all of them. Be a good little exercise for you to work on. Any questions about this problem? I think I have one more to work through with you. Any more questions on this one before I switch to the last one? Yes? Great question. So it doesn't like show anymore. It says that it's deprecated. Let's go look at the API and see if it doesn't like that. I don't know. So I think what it wants us to use instead would be a combination of show and pause. Pause is for waiting and show is for drawing. This command was doing both. I think what it wants us to do instead is I would not be so picky, but I think these are equivalent. Let's run it though, make sure. That's not the same. It's blinkier. I don't like that. Why is it blinkier? What did I do wrong? I mean, I don't know why it's flashing like that, but it's kind of okay otherwise. I wonder if that. Yeah. I think it's also worth messing around too with this value. So you'll notice it was 10 before. If I make it 100, that actually also has a significant effect on the motion of the ball. Because now, even though the velocity of the ball is the same, I'm waiting longer every time I draw a frame. So it looks like the ball is moving slower for that reason. Right? Yeah. The last example that I wanted to show, or this is actually an exercise, and it's not a bad one. What we want you to do is, so we've given you this animation loop. The exercise is pretty straightforward. It just wants you to grab the position of the mouse. So I'm now combining animation with the mouse. I want to grab the position of the mouse and draw something at that position. So it's up to you what that something is. I mean, this is not a super tricky example, but it is a fun one. So I'm going to grab the position of the mouse. And then I'm going to draw a shape of my choice, which I'll do filled square maybe. X, Y, half length of 0.1. I don't know. We can play with that. And I want my square to be blue. I'm going to make it blue. Okay, what did I do wrong here? I need to import the color. There we go. All right, had to fix that import. All right. So again, it has to be within the bounds of the window. You'll see that when the mouse is out here, it doesn't do anything. But once I move the mouse inside, it's following my cursor around. And the fun thing, I mean, I think one of the fun things about this is that, so the motion's pretty fluid right now. You can see it's hugging the mouse pretty tight when I move the mouse around. That square is staying pretty close. But if you come down here and you change the frame rate, right? Think about what that means. That means it's going to wait longer before checking to see where the mouse position is and drawing the square. So if I make this go larger, it's going to start to look like it's lagging a little bit. There's going to be a little bit of a delay or a little bit of a lag. You can kind of see. Now when I move the mouse around, it's just not hugging the mouse so tight. Or if I make this, even bigger, it'll lag even more. Right there, it's super laggy because I made the frame rate super slow. And then what can be kind of fun too, even though this is not the strict animation loop, if you turn the clear off, you can get to do some really cool stuff where it just, one thing that I've done in the past is like have it choose a different random color every time or a different random shape every time. You know enough that you could do that and make a fun little app that just draws funny patterns, colors, whatever you want. All right? A lot of cool stuff, a lot of fun stuff you can do. Okay. What questions do you all have? Because that's it. I intentionally, this week is, a little bit lower key, a little bit lower pressure. It's supposed to be anyway, because you just came off of an exam, so I didn't want to dump a whole bunch of stuff on you this week, but I hope this is a fun little topic for you. We have a really fun studio coming up this week on Thursday, so it's a very creative one. Asks you to draw some things, make some things up with your group members, so I think that'll be a lot of fun in class on Thursday. I'll be happy to stick around if you have any questions about anything I've talked about today, or if you want to come talk to me about some of the extensions or anything else. I'll hang around. Otherwise, I hope you have a good week, and I'll see you in class on Thursday. Thanks.